Hi friends, myself Professor Nalin Thakur. Today we will discuss about polarization drift velocity, polarization drift, gradient drift velocity, gradient drift, and curvature drift velocity, curvature drift when a charged particle is moving in electromagnetic field. First of all, you have shown my video drift velocity. It is like this. Drift velocity of a charged particle can be represented by electric field vector cross magnetic field vector divided by b square. You can see my previous video, I have derived this equation. This equation is key point equation. From this equation, we can get the value of any force exerted on charged particle moving in electromagnetic field multiplied by E divided by E into E equal to F. So any velocity can be represented by force multiplied by B divided by EB square. Please keep in your mind this equation with help of drift velocity and a new velocity. Any new velocity can be represented by force cross magnetic field vector divided by EB square. Now let us see here. In first case, ordinary drift velocities you can see here. Here electric field is ordinary electric field along the y-axis, along the j, and magnetic field vector is along the z-axis, k. Okay, this electric field is time independent, it is not time dependent. Okay, so we can get this type of drift velocities. Okay, you know that this type of drift velocity, yes, this ordinary drift velocity like this, E cross B divided by B square. But what will happen if the electric field is not steady but time dependent? What you should do, what we should write here? There is another type of velocity will produce, it is called polarization drift velocity, when electric field is time dependent instead of steady. So let us start. Okay, now you can see here polarization drift velocity. You see this picture, electric field is time dependent. Not only E but dE by dt is along the y-axis. Okay, and you can see B is a steady, B is along the z-axis. This is ordinary drift velocity along the x-axis like this. But what will happen if D is time dependent? So there is another type of velocity will be produced. It is called polarization drift velocity. How it is produced? What is the magnitude? What is the direction of this polarization drift velocity? Let us see. So first of all, let me say what I will discuss about any new type of velocity V equal to F cross B divided by EB square according to definition. And what is drift velocity? Drift velocity is E cross B divided by B square, equation number 2. Now again, what is our aim? Our aim is to find out this type of a force. Okay, so force equal to mass multiplied by acceleration, dV by dt. Okay, dV by dt, dE by dt cross B, B square like this. I place this value. So, force exerted on a charged particle when electric field is time dependent. So, new type of force is exerted on charged particle. So, new type of velocity will be produced in the system. Okay, what is it? So, V instead of V, we should write Vp. Okay, now let the place the value in this equation. Okay, place the value of F. Place the value of this F. This F value will be placed at here. Okay, so m d by dt cross B. Again, cross B. Okay, and EB square. So this is the value of force cross B and EB square is here. So we have placed the value of this force when electric field is time dependent. Okay, place value of here, and we can get another type of drift velocity. It is called polarization drift velocity. Now let's simplify it with help of vectoral position. Okay, A, suppose this part is called A, this is vector B, and this is vector C. Vector A cross B cross C. Okay, now vector A cross B cross C equal to B A dot C. Here you can say d by dt and B are mutually perpendicular each other. Okay, so d by dt dot B or B dot d by dt will be equal to 0. Please keep in your mind. Okay, so B A dot C, B A dot C. So B is here, B is here. Okay, this B is here. A dot C, dE by dt dot B, A dot C. Okay, these are perpendicular vectors. So dot product of A dot C will be equal to 0. These are perpendicular to each other, so dot product will be equal to 0. Minus A B dot C. So minus AM d by dt, okay, into B dot C, B dot B equal to B square, okay, and this 1 B square and 1 B square will be cancelled here. So final will be Vp equal to, minus sign is there, AM EB square d by dt. Okay, but this is the magnitude. What is the direction of this Vp or polarization drift velocity? Okay, so it is in the direction of dE by dt. Direction of dE by dt is along the y-axis, along the j-axis. Okay, so let me say here, this is along the z-axis, dE by dt is there, but sign is negative. So direction of polarization drift velocity is not along the j-axis or y-axis, but negative y-axis. Clear? Minus sign is there. So direction of polarization drift velocity is in opposite to that of the y-axis, and value is Vp equal to minus AM EB square dE by dt, and direction is along the minus y-axis. This one is called polarization drift velocity when electric field is not steady but time dependent. Okay, so you can see this is ordinary drift velocity Vd when electric field is steady, and this is polarization drift velocity when electric field is time dependent. So new type of velocity will be produced, and this type of drift is called polarization drift. Now somebody asks you, what is the current density Jp? J equal to NEV. Now place the value of magnitude of this. ये J की value नहीं डालो, और minus sign you neglect. Okay, then J equal to NEVP. So place this magnitude. Okay, so this will give you current density, polarization current density Jp. Okay, now let me again discuss about gradient drift or gradient drift velocity of a charged particle. Okay, charged particle is moving in inhomogeneous magnetic field. You can see this picture. Now. Here B is increasing along the negative x-axis. This is x-axis. Now B is increasing. Value of B is 5, 10, 11 Tesla, okay, 20 Tesla, 100 Tesla. It is increasing. So line of force, you can see this parallel line become dense and dense toward this. Okay, so this is called a gradient drift. I mean B is gradually increasing towards the center or along the negative x-axis like this. Okay, B, direction of B is along the z-axis, but magnitude of B is continuously increasing toward the center. This is magnitude is increasing. Okay, so now we can say the gradient B this type of a force, okay, produce Vg, this produce gradient drift velocity along the y-axis as follows. ये y-axis है, along this y-axis, how the gradient will be produced, how the gradient velocity will be produced. Let us see. Okay, you can see here, suppose here magnetic field become dense and dense. What will happen? Suppose any particle will be jump in a flow. What will happen? It will be flow towards the field. It is flow towards the field. Same thing is like that. Okay. So force, gradient force is proportional to minus gradient B. Why it is minus gradient B? Because you know that this gradient B force will be exerted toward the center. Because B is not same everywhere, it is increasing toward the center. So this type of a force, magnetic force toward the center along the negative x-axis. So sign is negative and minus I is there. So we can say that gradient force is proportional to gradient of magnetic field vector. Okay, so Fg equal to, this is magnetic moment is proportionality constant. Okay, grade Bi. Now again, from this definition, any new type of velocity can be represented by force multiplied by vector divided by Eb square. So place the value of force is here. Place the value of force is here. So Vg equal to new gradient drift velocity produced equal to, okay, place this value here. Okay, again cross B is along the z axis cross k. What is I cross k? I cross k equal to minus j, minus minus plus, it is called plus j. So value of gradient drift velocity is along the j axis or y axis. So gradient drift velocity is equal to mu grad B Eb square cross Bj. So whenever if magnetic field is toward the center, increasing toward the center, it is continuously increases, become dense and dense towards the center or along the negative x-axis. A new type of gradient force will be exerted on the charged particle. It is called gradient drift velocity. It is like this. Okay, so I have written it like this. So this is for electron and this is for positively charged ions, from this side to this side, from this side to this side, from electron. One is cyclic and another is anticlockwise. One is clockwise and another one is anticlockwise, but along the y-axis like this. Again, you can place this value. Mu equal to 1/2 mv parallel square divided by B. Okay, magnetic moment. And get simplified, you will get value. What is Jg? J equal to NeV. Place the value of G. Okay, then you can get current density, gradient current density. Okay, nothing else. Now let us study about curvature drift velocity. Okay, when charged particle is moving along the curved line of force in inhomogeneous magnetic field with parallel velocity, I mean velocity of a charged particle is parallel to this radial direction. Okay, this is VR. Finally, we will say what is the direction of this. Okay, force equal to, here centripetal force. Centripetal force is exerted on a charged particle. What is the value of centripetal force? mv square by r and unit vector r, because centripetal force is along the radial direction, is along the radius. So we have write like this. This is the value of centripetal force. Okay. Now, according to our definition, new type of velocity produced in the system is force multiplied by B, force cross B Eb square. Now place the value of this force. Place the value of this type of a force. Okay. yes, okay, mv square and value of r by r, you can see value of r by r, it is here, okay, r cap divided by r cross b divided by eb square, r by r equal to r cap divided by equal to r vector, it is vector, r unit vector divided by magnitude, it is a vector, you can see like this, yes, r r cap, sorry, r cap equal to vector divided by its magnitude, okay, so we have value, place this value, place the value of r cap, so r vector divided by r vector divided by r, again this r becomes r square, so curvature drift velocity, so let me say curvature drift velocity can be represented by Vr equal to mv square r cross b eb square, okay, the direction of Vr is along the y-axis, direction of this curvature drift velocity is along the y-axis, and Jr equal to NeVr. So in this way we can study more three type of velocity: polarization drift velocity, gradient drift velocity, and curvature drift velocity according to condition, which type of condition you are applied. But this one is key point equation. This one is key point equation like this. Please do remember. Okay. And drift velocity, ordinary drift velocity, when E is steady, it is given in my previous lecture. In YouTube previous lecture you should study about this, then you come across this type of different type of velocity. Thank you very much.